Okay, let's go over our test. This is 4D, and it looks like this is decaying, but it still doesn't matter. We do this the same process, so we have to take 4.46 divided by the one before, 5.25, and we get 84%, 0.95, and 379 divided by 4.46, enter, we get 84.97%. 3.22 divided by 3.79, 84.96%, and 2.74 divided by 3.22 is 85.09%. So 85-ish percent is being left. That means there's a decrease of 15%. 100% minus 15% is 85%. Let's find this one a little bit more accurately by adding these up. 84.95 plus 84.97 plus 84.96 plus 85.09. Enter. Divide by 1, 2, 3, 4 of them. 84.9925. So the average here is 84.9925, and so the decrease is 15.001. Because we take 1 from this. We take whatever this one comes out. If this was increasing, we would take this, we'd get 100 and something, and we'd go minus 1. Now we take this, minus 1, and it's a boop, boop, boop. Oh, in decimal form, excuse me, minus 1 from the decimal form. So I take 0.849925 minus 1, and we get, didn't hit the point. Insert the decimal, 0.8849 minus 1, we've got slow down, type it in correctly. 0.849925 minus 1 is a 15% decrease. The minus means it's a decrease. And if it was positive, if it was increasing, these would be over 100. And so we take 100 plus whatever, minus 100% or minus 1 from the decimal, and we get a positive percentage increase. So it's whatever this works out, this is in percent, so I'd subtract 100 from it, and that'll give us a negative 15, or we use the decimal version of this, which is 0.8495 for all these, and we'd get 0.849925, and we'd subtract 1, and we'd get the negative. So it's a decrease of 15%. 84%, 85% is left, 15% decrease. So the exponential model is, it's going to take however much there was in the beginning. In this case, there was 5.25, at time 0, at time beginning, and it's being multiplied by 0.0.849925 to the t. And that's how much after t years. It's an exponential model. And if I want to write it in base e, I just have to write this base in e, which would be e to the ln of that number, 0.849925. This is times 5.25. And this is to the t. And that would be the exponential model in base e. This is just a number that would be times this. It's going to come out close to negative 0.15 because this is the percentage increase or decrease. I can figure that out. We'll go on here and go natural log of 0.849925, and it says if it was continuously, this is not continuously compounded, if it was continuously compounded, it'd be minus 0.16 up here, or a 16% decrease. All right, so what's the half-life? So let's just use this model. Half-life means 1/2 of, if it's a decay, and this is a decay. If it's doubling, we'd want this to go to twice as much. If it's decaying, this would go to half as much. So this is a decay model, so this part has to be 1/2. So 0.08449925 to the t has got to be 1/2. Now to solve this, we write it in the same base. So this would be, as long as I did e here, it's going to be e to the negative, to the natural log of 8.849925 to the t, and that power comes down, so it's t times this equals e to the ln 0.5. Bases are the same, so the exponents must be the same. T times the ln of 0.849925 has to equal ln of 0.5. So I can divide both sides by this number. And I'll get how long it takes to double. Let's see what that comes out to be. ln 0.5 divided by ln of 0.849925. It's going to take about 4.26. To go to half, not double, to be half. 4.6 t is in years. Solve this. Well, they don't have the common base, so I'm going to write them with a common base. This, you guys like 10, so I'm going to go 10 to the log of 5. That's another name for 5. And that's to the 3x power. Equals, another name for 6 is 10 to the log 6. That's 6 times 10 to the log 3. That's another name for 3. And that's to the power 2x plus 1. All right. Now I got to try to simplify this a little bit. I want to get it down to 10 to some power equals 10 to some power. I got to use my power rules. If I got a base to a power to a power, the powers multiply. So I get 10 to 3x times this equals log a 10 to the log 6 times 10. So I got to multiply these powers because it's a base to a power to a power. So I got to take log 3 times 2x. And I've got to take log 3 times the 1. I got to distribute it to this quantity plus log 3. Now when you multiply with the same base, you add the powers. So I get 10 to the 3 times x log 5 as the power equals 10. I'm going to add this to this. This is a same bases, but this has an x, this one doesn't, so I'm just going to write it all out here. 2x log 3, that's just two numbers times x, plus this other power, log 3, plus this power. These powers will add. So 3 times x times log 5. This is all multiplication, so it can be done in any order. So I'm going to do, well, first of all, this, since there's a single base on both of them, must equal all of this. So 3x times the log of 5 must equal 2x times the log of 3 plus the log of 3 plus the log of 6. And this, I claim, is an Algebra 1 problem. 3 times the log of 5 times x is 3 log 5 is 2.097 x. Equals 2 log 3 times x. So that's 0.954 x. And then I have log 3 plus log 6. No x's on them, so I can combine those. Log 3 plus log 6. Log 3 plus log 6. Oop, forgot the parenthesis here. And that's plus 1.255. These are rounded off, so this is going to be an approximate answer. So I got some x's on this side, so I'll subtract them from both sides. And so I'm going to get 1.255 left on that side. And this side, I'm going to have 2.097 minus 0.954. I get 1.143x equals this. So I just divide by that. get x has to be approximately divided by my last answer, 1.098. Now, if I wanted to check it to make sure I got it right, I'll take 5 to the 3 times that number, 5 to the parenthesis 3 times 1.098, and I get just over 200 for this side. I should get just the same thing on this side. 6 times 3 to the power, parenthesis, 2 times my x, 1.098, plus 1, close parenthesis. That should be close to that same number if I've got the right answer. Barring the rounding, they are very close. So that is close to the correct answer. All right. Page 2. This says when we have our power rule, says if we've got a log of some base to a power, the power can come down times. So this is square root of 2 ln of e. And this says to what power do I take e to get e? That's 1. So 1 times the square root of 2 is square root of 2. Or you could have gone back here and said, to what power do I take e to get this? Well, the power that I have to take e to what power do I take e to get e to the square root of 2? I think the power has to be square root of 2. This says, to what power do I take 10 to get this? And then I take 10 to that power, so I'm going to get that. This is another way. Remember, we wrote 2. We could write 2 as log 10 to the log 2. It's another way to write 2. This is another way to write 5t. The 2 here can go up as a power, just like this can come down. The 2 can go up, and so this is e to the ln of pi squared. And so this is another way to write, because e to the ln 2 is 2. This is another way to write 2. This is another way to write pi squared. That's exactly it. Now I don't want the decimal, and I don't want the decimal, and I don't want the decimal. I want the exact answers. Exact answers. Okay. Now we have a log rule that says you add the powers when you're multiplying. So addition goes to multiplying. So this becomes log base 3 of x minus 6 times 3x. It's supposed to be 4. Now, if we're multiplying, we can go ahead and distribute this, and so we get the log base 3 of 3x times x is 3x squared. 3x times a negative 6 is negative 18x equals 4. Now, we can write this as a power equation, just like to what power do we take 2 to get 8? The answer is 3. 2 to the third is 8. These are interchangeable. This means this, this means this. This means, to what power do I take 3 to get this? I take it to the fourth power. 3 to the fourth is 3x squared minus 18x. If I got to solve for x and I got an x squared, that's a quadratic, and so I'm going to use quadratic formula, or I'm going to graph it, or I'm going to use factor it. I'm going to use one of my methods. But whenever you have a quadratic, you want it equal to 0. So I'm going to subtract 3 to the fourth from both sides. And 3 times 3 is 9. Another 2 3's. There's 4 3's multiplied, so it's 9 times 9, which is 81. So this is going to be 3x squared minus 18x. Subtract 81 from both sides. And I can put that in the quadratic formula. I could graph it. I could, and see where it is. This also factors. There's a 3 in all of these, so this is 3 times x squared minus 6x minus 27. So it's 3 times x and x to make 27, probably 3 and 9, and they would subtract to be 6. So if I go minus 9 and plus 3, I get minus 27, and I get plus 3x minus 9x, which is minus 6. To make this be 0, or if I graph this, it would go through positive 9 and negative 3. X would have to be positive 9, or x equals negative 3. Now, you cannot do logs of negatives. So if I put 9 in there, 9 minus 6 is positive. 3 times 9 is positive, so I can do that. So 9 should work. If I put negative 3 in there, negative 3 minus 6 is negative 9. Can't do that. 3 times negative 3, negative 9, can't do that. So this one can't be used. Sometimes both can't be used, sometimes both can be used, sometimes only one of them can be used. Now let's just go through and check this a little bit. This one happens to be pretty easy to check. If I put 9 in there, 9 minus 6 is 3. Plus, if I put 9 in there, I get 27. And that's supposed to be 4. So what power do I take 3 to get 3? I think that's 1. To what power do I take 3 to get 27? 3 times 3 is 9, times 3 is 20. I take it to the third power. 1 plus 3 does equal 4. Now I could type this into my calculator too. You should know how to do that. This is base 3. So to type this in, you do log of 3, and that's base 10, divided by log of the base, and it says it's 1. Now over here, I would do log 27 divided by log of 3, log of the base, and that should be 3. And 1 plus 3 is 4. Can you see that? That's kind of a fraction there. That's the 2 that I typed in. Okay. Next page. This one, we're supposed to solve this log equation. Subtract. You subtract logs, if they're the same base, when you divide. So this would be log base 4 of x plus 4 over x minus 1 equals 2. Now I'm going to write this as a power. To what power do I take 4 to get this? I take 4 to the 2. 4 squared equals x plus 4 over x minus 1. Don't like the fraction, so I'm going to multiply both sides by x minus 1. Those cancel. 4 squared is 16, so I get 16x minus 16, distributing the 16, equals x plus 4. Have an algebra 1 problem. I'll subtract x from both sides. 15x minus 16 equals 4. I'll add 16 to both sides. 15x equals 20. Divide both sides by 15. And x equals 20 over 15. 5 goes into both. I could reduce this to 4/3. Now I should check. 4/3. 1 1/3 plus 4 is positive, so it should work. 4/3 minus 1 is 1/3. That's positive. Should work. And if I wanted to check it completely, I would go log of 4 plus 4/3 but it's in base 4, so I have to divide by log of 4 minus log of 4/3 minus 1. That's 1 1/3 minus 1 is 1/3. Divided by, since the base is 4, I have to divide by log of 4. And this should come out to be 2. Okay. This is the continuously decaying model. There's a K. It should be negative if it's decaying, and that's what radioactive isotopes do. So I need to find the K for iodine 131. That's the chemical they put in your blood so they can do scan for some problems. So to figure out the K, if they're saying that exactly 6.2500 E starting amount E2, the constant for this times the number of days it takes to get to there, 4 days, we'll get down to 4.4232. So there's 5 digits of accuracy, 5. So we should probably be able to do K to 5 digits of accuracy. So I should get this out of here. So I'm going to divide both sides by 6.25000. So 4.4232 divided by 6.2500 is 0.707712. Equals E to the 4 times K. K times 4, 4 times K. Looks better that way for me. So I need to have the same base, so I'm going to write this as E to the ln of 0.707712. Have the same base, so the powers must equal. So 4 times the constant must equal ln of 0.707712. Divide both sides by 4, and I get the K. So I want to do ln 0.707712 close parenthesis, divided by 4, and this is the K for radioactive iodine 131. K is equal to negative 0.0864295.3. I'll round it off. So now, what if I started with 2 grams? Not this amount, but 2 grams. E would be to this power times how long I want to go after 10 days. So I'm just going to figure out 2 grams to start with. E to the K, which we figured out is this K, times 10 days. So I got 2 E to the power of K, which is that last answer, times 10. And if you got a different calculator, you'd have to put the power in parentheses. This kind of calculator, you don't have to. And we get 0.8426 grams left of our 2 grams. 0.8 of a gram would be left after 10 days. Okay? What's the half-life? Well, the half-life would mean that 2 would go to 1, which means this, what we're multiplying by, and this would be K, wouldn't know the T, but this would have to be 0.5. 0.5 would be what E to the KT has to be. So 0.5 would have to be E to this K times some T. We're trying to find out when these are equal. Well, 5 is E to the ln, 0.5 is E to the ln 0.5. So to figure out T, since these are the same base, this must equal this, equals K to the T. K is that number up there. So I divide by that number, divided by the K, and that should be how long it takes for half of it to be left. So I'm going to go to ln 0.5 divided by negative 0.08643, and I get 8.01 days. 802. Rounded off. That's how long it would take for it to be half as much. Okay? Last page. And I gave you the compounded formula and compounded continuously formula. $3,000 is starting amount, that's A0. Interest rate of 5.75. 8 years compounded monthly. Monthly is 12 of them in a year, so N is 12. So starting amount, 3,000, parenthesis, 1 plus interest rate in decimal, 0.0575, divided by N, 12. This is what we'd multiply to find out after 1 month, but for a year you'd have to do it 12 times, multiply, that's why that's that power. And if you're going to do it for 8 years, you're going to have to do it times 12, 8 times. So this is what I got to type in to figure out. 3,000, parenthesis, 1 plus 0.0575 divided by 12, close parenthesis, to the open parenthesis, 12 times 8, close parenthesis, and there would be 474700. $4,747.00 after 8 years at this interest rate, compounded monthly. How long to get 5,000 compounded quarterly? Quarterly, there's 4, n equals 4. We want to get to 5,000. This got to 4,000, so it's going to be a little longer than 8 years, and it's not, instead of 12, it's going to be 4, so we're going to 3,000. We want to end up with 5,000, starting with 3,000. 1 plus same interest rate, 0.0575, compounded quarterly. 2. So we got to put 4 times. We got to multiply this for 1 year, and then we're going to do it for 8. We don't know how many years to get to 5,000. So we got to solve for the power. So we'll divide by the 3,000. 5,000 divided by 3,000 is 5/3. So we get 5/3 equals 1 plus 0.5057 divided by 4 to the 4t. So I'm going to write this in logs. You can do base 10 or BC. So this would be 10 to the ln of 5/3 equals, log, base 10, 10 log of this 1 plus 0.0575 divided by 4. Oh, this part divided by 4, close parenthesis, to the 4t. A power to a power, this comes down, times it. Then I'd have the same base, so log of 5/3 has to be 4t, the power comes down, times this. Log of 1 plus 0.0575 divided by 4. The power came down. So to solve this, I'm going to type in that divided by the 4 and this. So I'm going to write, yeah, I know, log of 5/3 divided by, now this is going to be a bunch of stuff, so I'm going to put parenthesis. I'm dividing by the 4 and the log of that. Parenthesis, no, it already did parenthesis. 1 plus 0.0575 divided by 4. And I get that the t would be 8.948 years. How long for it to double if compounded daily? If I'm going to take some starting amount and make it twice as much, that must be 2. The 1 plus the interest rate, 0.0575, divided by daily is 365. All of this to the 365 times however long it takes to double has got to be 2. this has to be 2, so that 2 times the starting amount gives me twice as much, doubled. So again, we write this in a common base, 10 to the log of 2 equals 10 to the log of this, 0.057, 1 plus 0.0575 divided by 365, and the power would come down times 365t. So this has to equal this, like we did before. So I'm just going to be log of 2 divided by all the non-variable parts of this. So it's going to be log of 2 divided by a mess. I've got to divide by the 365, not the t, but the log of 1 plus 0.0575 divided by 365, close parenthesis, and it says it would double in 12.055. How much is in the account after 8 years if compounded continuously? Let's just plug it into this formula. Starting with, what was it, 3,000? E to the interest rate times the time. E to the interest rate, which in decimal is 0.0575 for 8 years, times 8. We just got to figure that out. 3,000 E to, we've got a couple things, so on most calculators you have to put a parenthesis, 0.0575 times 8. And it says there'd be $4,752.22.